Hey, what is up everyone? My name is Sukanto Roy and you're watching Coding with Roy. So welcome to yet another video of the Python interview question series. This is the 10th video of the series, and in this video and the upcoming video, we are going to talk about Python memory management in depth with code examples and everything. We are going to get into all the nitty-gritty details. Timestamps as always will be in the description. So if you want to move to a specific part of the video, feel free to do so. And if you are liking this content, please subscribe to the channel and click the bell notification so you get notified whenever I upload any new video. With that being said, let's get into the core part of the video. So today's topic is how memory management works in Python. This is also a very famous Python interview question. It falls definitely in the advanced category of things. So if you are going for a Python developer position, then probably the interviewer will expect that you understand internally how Python memory management works. In this part of the video, we are going to specifically target reference counting as the method of Python memory management. The second part will deal with another form of Python memory management that is called generational garbage collection. So let's get started with this part. So let's first understand what is memory management and why is it needed. So to understand memory management, let's think of it as a empty house. We can imagine computer memory to be an empty house, and all the processes that are there in a particular computer when we are running a program, we can think of them as things. Like, say we can think of one process as a couch, another process as a bookshelf. So let me show you by this diagram. So imagine this is a memory house. So it represents the internal memory of a computer. And all these small boxes you are seeing, imagine them as processes. In this context of the memory house, imagine them as, say, this is a couch, this is a bookshelf. In this way, every particular process or every particular thing is going to require a certain amount of storage. And whenever you want to allocate another particular process into this memory house, you have to make a space for its own usage. Okay. So where memory management comes is, say we have a lot of processes running and the whole house is filled like this, and there is no particular space for any other. Say there is this process that is asking for permission, like, can I get a place in this particular memory house? And you are saying, okay, the memory manager is basically will be like, okay, my task is to allocate this process a particular memory. So what I can do is, I can take all of these and see which of them are least used or not used. So if, say for example, this particular process is not used in a long time and no other process is using it. So in this particular context, we can think of it as like this particular thing is not being used in this house. So what memory manager will do is, it will delete this, and then we will have a space for this particular process as well, and we can fit it. So similarly, when there will be a new process coming, so say again a new process is coming and then there is no another place, so the memory manager will again do the same process of checking which particular process it can remove so that this process gets a place. So say this particular process is not getting used, so it deletes that, it removes that, and we get another space for this particular process. So this is the task of a memory manager. So basically, a memory manager's task is to allocate and deallocate memory. So whenever we are running a program, all the processes inside that program will require some form of memory. Say you are creating a list, it will require some memory. You are creating an array or a dictionary, or you are doing any number of things, it will require certain amount of memory, and that memory allocation is the task of the memory manager. So what memory management means is allocating and deallocating memory for a particular task or any task. So now let's see how Python does memory management, how Python performs memory management. So Python does not give you the control of memory management like you have seen in other programming languages like C. The memory management part in Python is automatic. With that being said, I have to again mention that there are some aspect of memory management that you can control. We will see them in the later part of the video, like not this video, the next part of the video. We are going to see how using the GC module in the garbage collection module in Python, we can like modify something. We can disable that particular GC module so that the garbage collection automatically will stop, and we can manually do all of that. But for the most part, we are not going to use memory management. We are not going to manually do memory management for any Python program. It is automatically taken care of. So there are mainly two ways in which Python does memory management. One is through reference counting and the other is through generational garbage collection. So these are two methods using which Python does memory management. Now let's see the other part, variable as memory references. To understand reference counting, we will first have to understand how variables are treated in Python. So in Python, everything is an object. We have discussed about this particular concept in previous Python interview question videos as well. In Python, everything is considered an object. Even the integers, your like the 5, the 2s, these kind of integers, the floating point strings, everything is an object in Python. Obviously the list, tuples, these are objects, and variables are not containers that store those objects. Okay, so variables, you cannot think as them as containers that are storing the object. Variables, what they are doing is they are storing the reference to the memory. So using this particular diagram, you will understand. See, imagine this is a memory heap. Okay, and this memory heap has a lot of blocks of memory, and all these are 0x1000. Imagine these are the addresses. I am running a statement as a equals to 5. So what internally happens is Python creates an integer object with a value of 5. So 5 is an object. It is an integer object, and it places that particular object in any block of the memory. And when it is placed, it creates a identifier or variable that is named as a, and that variable stores the address. So you can see here, this particular a variable is storing this address, not this value of 5. The 5 is stored in the memory heap as an object. So once you have understand that variables are nothing but references to the memory address, so now we can talk about what is reference counting. So reference counting is nothing but a count that represents how many particular places are referencing this particular object. How many places are referencing this particular object. And what reference counting does is, Python memory manager through reference counting checks how many objects have reference count of 0. If any particular object has a reference count of 0, that means that there is no object that is using this particular object. So Python memory manager removes that particular object. So that is how it deallocates memory. But we are going to see in the later part of the video, it is not a complete plan. There are cases where this does not work. This reference counting does not work. So now let's understand from this particular diagram how reference counting works. So say I have a person class. The person class is going to, and this a variable, in this a variable I am assigning a person object. I am creating an object of person class. What will happen? In memory somewhere I will have a person object created, and then what is going to happen? I will create a variable a that is going to reference to this particular person object. As we have seen in a previous diagram, when I was showing you the variable memory references, we have seen that variables are nothing but memory references. So in this way, a variable is referencing to this person object. Now, this reference count, or here I have mentioned ref count, is 1. Why? Because only a is referencing to this particular object. So this particular object is being referenced by A. So the reference count is 1. Now we have mentioned B equals to A. So when we are mentioning B equals to A, what is internally happening is Python is again creating a variable B, and it is pointing that to the same person object that is in the memory heap. So what is going to happen? This ref count or reference count is going to increment to 2. So this is how reference counting works. And now if I remove this, if I make A equals to none, this reference counting again will become 1, because only B is going to reference to this particular object, and A's this particular link is going to vanish. Similarly, in case of if I am again doing B equals to none, then this link is going to disappear. Then the reference count will be 0. And once the reference count becomes 0, the garbage collector is going to collect this, saying that okay, so this person object I see is not being used by any of the program, any of the variables or anything. So this is unused. So I am going to remove it. So it will remove, and we will not be able to see this particular person object anymore in the memory. Now let's understand how to find out reference count of any variable. So we will see some code examples. So let me show you quickly a code example of this particular thing. So we can find out reference count using two methods. One is using the sys module, and another one is another ctypes module. So there are two ways in which we can use, like we can see reference count. Now you will see in this sys module there is a drawback. I'll show you. Say I have creating A equals to a list 162, okay, anything, and now I am creating this. So one thing you will have to remember is, say as I mentioned that variables are nothing but memory references. So there should be, they should somehow, if you are say printing this, you are printing the list, so there should be some way to access which ID is contained inside the variable. So we can mention that with ID method. So this is the memory address where this particular list is stored. We can also see it in the hex form, hexadecimal form, to get a smaller number. So this is the hexadecimal form of this particular ID. So this is the memory address where this particular list is being stored. Now as A is pointing to that, let's see what is the, we are importing sys library, and let's see what is the reference count. Now you will see this reference count of A is going to be 2. Why it is going to be 2, I'll tell you after I show you. Get ref count, and we are going to pass this variable A. So once we pass it, we will see the reference count is 2. So why is it 2? It is 2 because the reference count, when we are passing the variable, we are passing a reference to this particular object. So to understand this, you will first have to understand how functions are treated in Python. So Python treats functions as first class citizens. So they can be passed around as object as well. So to not go into the depth, what is being done here is, when we are passing A, we are not passing this particular variable. As I mentioned, variables are nothing but memory references. When we are passing this, we are passing a reference again. So when we are passing the reference to this particular object, then this get ref count is also referencing this particular list. So this is in official documentation. You will see that when you are going to get ref count, you will see one increased ref count. So if the original ref count is 1, you will see the ref count being 2, because this particular get ref count method is also referencing to that particular object. So mainly it is 1. And now let's see, let's make B equals to A as well, and now let's see the reference count as we have done in the previous examples. So now you can see that I passed B. I can easily pass A also because both of them are referencing to the same object. Now the reference count is 3 because B is also referencing to the same object. Now if I do something like A equals to none, now A is not referencing again, so we lost the connection with A. We can only get to this list through B. So now if we see print sys dot get ref count and we pass B, we are going to see the reference count has decreased to 2. Now if we are again going to say B equals to none, then we are going to lose that particular object. Okay, so this is one way of getting the reference count. There is another way of getting the reference count, and that is through the ctypes module. So the ctype modules does not take memory memory references like this one. We are not going to pass variables to ctypes module. We are going to pass the raw address. Say x, let me take a fresh example. So say x equals to 1, 2, I am taking a list and I am creating one quick say function that is going to return me the reference count, so that I don't have to always print the long expression that I need in ctypes module. So I'll show you. So what this particular function is going to take is it is going to take the address, the raw address, and it is going to return ctypes. From ctypes I am going to access the clong module, and from them I am going to address the from address module I am going to take, and I am going to pass the address here, and then I am going to access the value attribute. So this is how it is done. We can get the reference count, and this reference count is going to be the raw reference count, not increased by 1 as we have seen in the sys module. So let me quickly show you the ID also of this x. Now we are going to let me take it as in a x ID. Let me take it in a variable because we are going to again make it null, and in that case we need the ID. So now x ID has this, so we are going to get the get ref count of x ID. Let's print it. Okay, some error happened. Oh, I forgot to import ctypes. So it should work now. Integer expect. Oh, okay. A hex converts it into like string. So I can also take the raw hex, but I cannot. I have to change it. So let's, for this example, take the decimal ID. So now you can see the reference count is now 1. So we can also again do y equals to x. When we are going to do y equals x, we are going to get the, say again I am taking this particular get ref count. Now we can see it is incremented to 2 because y is also like referencing to this particular object. Now again, if I am showing you again once again, we are making y equals, say we are making x equals to none. Now if we again see this particular example, we will see it is getting, it is getting decremented to 1. So this is how you find out reference counts of Python object. So now let's see other parts also. So what is the drawback of reference counting? So this is a very simple approach, Python memory manager. This is a very intuitive approach. Python memory manager takes the reference count. When it becomes 0, it cleans up the whole process. So this is a very easy way to do memory management. What is the caveat? So there is one caveat, and that is memory like reference counting works great, but not when you have something called circular references or reference cycles or cyclical references. Anyway, you will see different blogs like mentioning this particular topic, but the main idea is this, that what is circular reference? Say you have a similar statement A equals to person, and you are creating a person object, but this person object has a clause where it is like, say we have a class person, and in that class we have an attribute pet. So there will be a person object, and each person object is going to reference to a particular pet object as well. And in that pet object also there is one attribute owner, and that pet object also is going to reference to the owner of that particular pet. So you can see this person object is referencing to this pet, and this pet object is referencing to this owner. So when you are going to execute A equals to person and you are going to create a person object, then a variable A is going to reference to this person object. Now what is going to happen when you are going to like do something like A equals to none is this particular link where you are referencing to this A is variable is referencing to this object, person object, is going to get removed. So there is no way in which we can access this person object, and there is no way we can access this pet object. But this person object is referencing this pet object, and this pet object is referencing this person object. So both of these are going to have reference count as 1. They are not going to be 0 anytime. So this is a problem of circular references, and reference counting cannot solve this problem. And to solve this problem, we need something that is more sophisticated, and for that we will see the tracing garbage collection algorithm, and that will be in the next part of the video. So in the next part, what we are going to do is we are going to show with code examples what circular references are and what generational garbage collection is. So this will be the next part of the video. Hope you found it very helpful. Hope you found it informative. Thank you very much for listening till now. Like, comment and subscribe. I am going to bring a lot of informative content in the future. So be a part of this community. Thank you very much. Bye.